The basics of naming chemical compounds for Chemistry 134. This material is divided into four parts. The first part is the periodic table, and it just sort of lays out how you can determine the charges on the periodic table. If you're comfortable with the periodic table, you can skip this part. Part two is simple binary systems, so a metal with a nonmetal, and it goes over the nomenclature of metals that can have different charges. Part 3, polyatomic ions and oxoanions. This part is crucial. I would really encourage you, even if you're comfortable with nomenclature, to go through this part, because I try to make a lot of connections with the periodic table, and I explain polyatomic ions that maybe you're not too familiar with. Then there are acids and bases and covalent molecules. When you take Chemistry 134, it's expected that you've learned a certain amount of chemistry coming into the class. For this particular series, we hope that you can look at an element symbol and be able to identify that element by name. And that includes spelling the name correctly. You must be able to spell things correctly, especially when you're using mastering in chemistry. The goals in this series, you should be able to locate metals, nonmetals, and metalloids on the periodic table. You should be able to associate the location of the element on the periodic table with the naming convention. And you should be able to name and identify fundamental chemical formulas. Here is an example list of anions and cations that you're expected to know for Chemistry 134. If you look at this list, it's a rather complicated looking list, and if you just try to use brute force memory, you're going to have a lot of challenges to try to remember all of these symbols and compounds. So what we're going to try to do in this series is relate everything to the periodic table. If you can look at the periodic table, identify the element, figure out the charge, then you could construct the name or the formula from the name, and it makes it a lot easier to be able to use the periodic table. So you can try to brute force memorize this, but that's probably not a good idea. In part 1, we talk about the organization and layout of the periodic table. So let's begin with looking at a periodic table, and this is an example periodic table, very similar to the one that's in your book and probably something you'd get on your exam. So you see that this particular periodic table has the element symbols and it has the element names in it. So I said earlier that you needed to know the symbol and the name. That's actually true only for the first 3 rows. You will learn more of them as you use the periodic table, and so it's not expected that you should sit down and memorize everything. You should probably have a basic periodic table here which has the symbols and the element names, and then as the semester progresses, you'll gradually learn more and more of the names. So let's classify the elements, and in general, when you look at a periodic table, there's 3 classifications. You look at elements as being metals, nonmetals, metalloids. The most common elements on the periodic table are the metals. So here, if I take that periodic table now and colorize the metals with purple, you can see that the vast majority of the elements are metallic. You can also see that in general, the metallic elements are on the left side of the periodic table, and they tend to be towards the bottom. The nonmetals are the elements in the upper right-hand corner of the periodic table. Also hydrogen, which is often put on the metallic side, hydrogen is a non-metal. It's put with the metals because of its electron valence, and that's something you learn later on in the term. So we won't talk about that now, but you should remember that hydrogen is a non-metal. There are a total of 17 non-metals, and here they are listed again. 5 are solids at room temperature, so that's the elements in their elemental state. 1 is a liquid at room temperature, that's bromine, and 11 are gases at room temperature. So these are typically the noble gases that we refer to: neon, argon, krypton, and so on. Hydrogen is also a gas, and nitrogen, oxygen, fluorine are gases. Metalloids, this is a group of elements that are between the metals and nonmetals. And typically, we identify those with a solid line through the periodic table. If you look at that solid line, you'll note that boron is a metalloid. Carbon, however, is not. Following that line down, silica is a metalloid, phosphorus is not. And then you get to germanium and arsenic, those are metalloids. And then antimony and tellurium, those are metalloids as well. So the line is just kind of a loose guide to identify where the metalloids are. You could it's probably easier just to memorize the 6 metalloids that exist. All right, back to our periodic table. We've got main group elements, and main group elements consist of both metals and nonmetals. And these are on the perimeters of the periodic table. So hydrogen through francium, beryllium through radium are main group elements, and then the region of nonmetals, boron, diagonally down to radon are main group elements. Another important group of metals are the transition metals. Those are in between, and we're going to talk about those because they have a variable charge. Okay, so let's talk about ions. This is where we take an atom and we remove or add electrons to it. So the number of electrons in a neutral atom is equal to the number of protons in its nucleus, and this is designated by the atomic number Z. So what makes an element is the number of protons. We can, however, strip off electrons or add electrons. We still have the same element, but we refer to it now as being an ion. So if it's not neutrally charged, it's an ion. Positively charged ions are cations. Negatively charged ions are anions. So if you add an electron to an element, it becomes an anion. One more electron makes it negative. And if you remove an electron, it becomes positive. So we call that a cation. So a cation is an ion with a positive charge. If we consider sodium as our example, there are 11 protons in sodium. And if I strip off an electron, I have 10 electrons. So I have one more proton than I do electrons, and so it has a positive charge. If I consider an anion, a common anion is chlorine. So here I have 17 protons on chlorine, and if I add an electron, I get 18 electrons. So I have one more electron than protons, therefore it has a negative charge. If you've ever looked at a battery, often you refer to the anode and cathode on the battery. So the cathode is typically the side with the positive charge, and the anode has the negative charge. So it's a lot like ions. So let's look at the periodic table in terms of the charges that form on the elements. And at first, we're just going to look at main group elements, so the left-hand side and the right-hand side of the periodic table. If we look at just the left-hand side, those are the metals, and the metals are elements that tend to lose electrons. So they're going to have a positive charge, or they're going to form cations. If we look at the group 1A and 2A, 1A are called alkali metals, and 2A are called earth alkali. So typically the alkali metals, they will lose one electron, and they'll typically have a positive 1 charge. The earth alkali will lose 2 electrons, and they typically then have a positive 2 charge. Now, the only time they really lose an electron is when they're with another element. So if they're with another element, or if they're in water, they can be a positively charged. If they're, the element itself, it's very difficult to pull that electron off and not have it be with something else to react with. So on the other side of the periodic table, we have the elements that form anions, or the nonmetals. So the nonmetals have to gain electrons. And here we have the naming convention also. 7A are called halogens. 6A are called oxides. And actually I don't have them listed here, but 5A would be the nitrides. 4A would be the carbides. What's special about 7A and 6A is 7A are elements that typically, when they acquire an electron, they can only acquire one, and that gives them a single negative charge. 6A acquire 2 electrons, and so they have a -2 charge. Also, I left out the nitride because nitrogen is really the only element that can acquire up to 3 electrons, and then it becomes, of course, the nitride. So, in general, I end up with a series of rules that will help us name our compounds. And the rules, again, associating it with the periodic table, group 1A has a tendency to lose 1 electron, and so they form +1 cations. Group 2A, they tend to lose 2 electrons and form +2 cations. The halogens, group 7A, they tend to gain an electron, so they form a -1 anion. The oxides, they tend to gain 2 electrons and form a -2. And what's important about this small set of rules is it allows us to look at compounds and almost immediately determine the charge of particular elements. So if you see it's a 1A, you know it's got to have a +1 on it. And that's going to help us figure out the name of the compound. So back to our periodic table. We also have this group in the middle involving the transition metals. And transition metals are special in that they can have a variety of charges. And we're not going to worry too much about all of the transition metals, but there's some that we commonly use in laboratory that we really need to know what those charges are. So looking at a smaller subset of the transition metals, these are first row transition metals, chromium through zinc. We're going to be responsible for knowing the charges on these metals. And the good thing is they typically are either +2 or +3. There are some other metals. We've got silver, gold, cadmium, and mercury. We need to know the charges of these, and they have some variety of charges. And then we have tin and lead. And so these are main group metals, and their charges are important because we typically use these in laboratory.